So this is a Chapter 9 review on linear relations. There's 4 questions, and 4 of them are kind of basic. They're not too complicated. The first one, you're given a graph. And this graph could mean a whole bunch of different things. It could mean, if we did that pizza thing, it could be number of toppings, or sorry, it could be T, which would be number of toppings. If we wanted to make this into a context, we could. And we could do the cost of whatever it is for a pizza. We could say if there's 1 topping, your pizza will cost $6. If it was 2 toppings, your pizza would cost $8, and so on and so forth. And we could figure out what this means. So the first thing we would do is translate this graph into a table of values, and we call it the T of V, right? The table of values. So I'm going to break it down into here, and I'm not going to call it T, I'm going to call it X and Y, just because there was no context. I just made that. And when X was 1, I can go down here to 1. And when X was 1, the corresponding Y value was 6. So when X is 1, Y is 6. When X was 2, Y was 8. And finally, the last one, when X was 3, Y was 10. So that's translating a graph into what we call a table of values. And once we have it in a table of values, we can then determine what equation or what relationship X and Y have to each other, because there's a consistent relationship between the two. And that can be written in mathematics as an equation. So what we want to do is we want to find 2 things. We want to find out, what do you multiply X by something? Do you add something to X, or do you both? Do you multiply and add or subtract something from it? So basically what we're saying is we determine the equation, and we determine if there's a coefficient and whether or not there's a constant. So when we look at this, the secret is we can determine the coefficient of our equation between X and Y by looking at the difference in the X column. This case is going up by 2, and it's going up by 1. And we said earlier that the coefficient of an equation is the difference of Y. And in fact, we're going to skip ahead right here. What is the formula for the coefficient? The formula, this is question 4. The difference in the Y column divided by the difference in the X column, ENCE, will be my coefficient. So the difference in this X column, if we go back here, the difference in the X column is 2, and the difference in the Y is 1. So I will write that as 2, positive 2 over positive 1, and that difference, 2 divided by 1, will be 2. What that means is, in the relationship between X and Y, I know that 2 is going to be my coefficient. And what that's going to translate to later on in grade 10 is what is the slope of the line, okay, the steepness of the line. So 2 is going to be what we call the slope, but we're going to call it the coefficient of our equation. And once we know that that's the coefficient, I can then take any of my ordered pairs, and the first one's always the easiest, and substitute the X value and substitute the Y value and see if they're the same. If they're the same, you do not require a constant. If they're not the same, then you have to think about what constant do I need to add to my X side to make the 2 sides balance. In this case, I need to add 4, which means plus 4 is my constant. So this equation, 2x plus 4 equals y, is the equation that matches the line. Now, I'm going to do question 4 as well again. The other thing that we need to understand about that equation is this y-intercept. And the y-intercept is always the constant in your equation. And that's what the y-intercept is. The constant in your equation will be the y-intercept. And if I go back there, that line, if I was to extend it, and I know my line's crappy, but if I drew the line a little bit, maybe, oh, there it is right there. That's not bad. If I look at where that line crosses the y line, or where it intercepts the y, it actually intercepts the y at positive 4, which is an indication of my constant, what it is. So if this was a question of toppings and pizza, then I would know that it costs $2 per topping, and it's $4 for a plain pizza, right? So if I wanted to say, if I wanted to buy, this is T now, not X, and this is C for the cost. If I wanted to buy a 10-topping pizza, I could substitute 10 into my X, and it would be $2 per topping, times 10 would be $20 for the pizza, or for the toppings, plus $4 for the pizza. It would be $24 in total for that pizza if I had 10 toppings, right? And we could use that by just figuring out with the equation what things would be. If they allowed me to have 1.5 toppings, I would also be able to go in between here and figure out that 1.5 toppings, based on my graph only, should cost me around $7. And I could also substitute 1.5 here for 2, which would be 2 times 1.5, which is 3, plus 4 would also tell me it would be $7. So we can use the graph to determine values, or we could use an equation to determine values that are beyond what we already know. And that's the purpose of the linear relation. In the second question, we're given the equation, and the expectation is with an equation you can make a table of values and then graph it. So for this one, some people are having difficulty figuring out, well, I can make my table of values, but I have no idea what numbers I put in it. When you're given an equation, generally speaking, you just want to put 3 or 4 simple numbers. 0, 1, 2, and 3 is always a good starting point. Okay? So if x is 0, I could substitute it in here. And 4 times 0 is 0, and 0 plus 1 would mean y is simply my constant. So this is interesting. If you go back to that graph, when x is 0, here's 0 on the x-axis, right? And if I go up, when x is 0, y is simply my y-intercept, right? Where it's 4 on this one. And it's also where it crosses the line. So when x is 0, in this case, this is really just telling you your constant. It's always going to be just your constant. When x is 1, y will be 5. When x is 2, 4 times 2 is 8. 8 plus 1 is 9. And when x is 3, I better just write it again, that would be 12 plus 1. Your y value would be 13 here. Okay? So once I've written my equation, I can substitute those values, and now I have 4x plus 1 equals y. I have my table of values, and the last thing I have to be able to make is my graph, which will be 1, 2, 3, and 4 on my x-axis, or 5 if I want. And up here I got to go to 13, so I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. When x is 0, y is 1. When x is 1, y is 5. When x is 2, y is 9. When x is 3, y is somewhere around there. That is my graph that matches it. Okay, that's as easy as that. So if I wanted to figure out what was 2.5, I can go up here like this and figure out that 2.5 must be whatever. Okay. Your third question, you're given the table of values. You need to determine the graph and the equation. Of course, the easiest thing if you're given a table of values is to simply graph it. So here is my graph. X is 1, y is 3. That'll be here. X is 2, y is 8. That'll be here. X is 3, y is 13. I don't know, roughly here. And x is 4, y is 18, roughly there. And if I connect those dots, if my graph was reasonably accurate, that line would be perfect. To determine the equation, to show the relationship between x and y, we are going to first look for the coefficient. The difference here is 5. The difference here is 1, which means 5 divided by 1 is 5. Once I have that, I'm going to substitute my first ordered pair, 1 here and 3 here. Determine if they are equal. Does 5 equal 3? No. I would need a constant of -2 to keep them balanced. And therefore, the equation that matches this line is 5x minus 2 equals y.